Okay, this is question 14 from Specimen paper 1. And it's a differential equations question, but what's really difficult about it is that they have expressly asked you to rewrite dn dt in a particular format. So they've wanted you to write it in that particular format, which is what makes this question really difficult. But it is the last question on this paper and it is worth 9 marks. Right, so the first thing we do is we take what they've given us, and what you've got to be able to do is to get all your terms with an n in onto the left hand side. So to do that, the first thing that I did was I rewrote that bracket over a common denominator of 50. So I rewrote the 1 as 50 over 50. And there were loads of things I could do here, but because I could see by looking at what I'm supposed to prove that the power of E is minus 0.1t, I knew that I needed to keep the 0.1 separate. And I also spotted there was a 50a on the top, so I knew I couldn't combine it and make it 500 or 5 or anything like that. So I kept them separate. So what I've then done is I've divided both sides by 50 minus n, I've multiplied by 50 and I've divided by n. So I've kept it in this format, and that's going to make it easier for me to achieve the answer that I need. So I'm now able to integrate both sides. Now, on the left, the hard integral, it's a fraction. So I go through my mental checklist. I can't split it up over a common denominator. The derivative of the numerator is not, the derivative of the denominator is not the numerator. I can't use Miss Awan's formula. But I have noticed that that denominator is factorised, and that means partial fractions. So I'm now going to split up the left-hand side. So I'm going to step outside the question and split that up over partial fractions. Now, the denominators are both linear factors, so it's just my A over my A and B, and then I've got them over my common denominator of n bracket 50 minus n. Of course, you're really well practiced at that, so I'm just sort of skipping over that a little bit. And now I substitute n equals 50, I get b as 1, I substitute n is 0, and I get a as 1. So I've managed to rewrite my integral in that format. Now I've split it up into 2 separate integrals just because I find that easier to be able to integrate the 1 over 50 minus n. So I'm now going to rewrite my integral of 1 over 50 minus n. I know that's in the form where the integral of, well, the derivative of the denominator is the numerator, so I make that numerator -1, and of course to do that it becomes a takeaway for the integral. So I'm now going to integrate both sides, and I've rewritten my left hand side using law 2 of logs as ln n over 50 minus n. Now, to undo the natural log, I make both sides powers of e, and I know that on the left hand side that e to any natural log power is just that natural log power. On the right hand side, I've used laws of indices. I know that when I multiply 2 bases together, that I can add the powers together. So I've just split up the powers over the base. Now, I also know that e to the c is just a constant, so I'm going to call that constant capital A, basically because that's what they've called it in the question. So I've rewritten it like this. Now, all the time I have one eye on what I'm trying to prove. So here I'm now going to multiply both sides by 50 minus n. I'm aware that I need to make n the subject. I'm now going to, because I've spotted, and the only reason I'm doing this is because I can see it in what I'm trying to prove. I now divide both sides by e to the 0.1t. And of course, dividing by e to the 0.1t is the same as multiplying by e to the minus 0.1t. I then expand the bracket on the right hand side and I add capital AN to both sides. I'm now going to take out a factor of n on the left hand side and I now divide both sides by a plus e to the minus 0.1t, and you have proved what they've asked you to prove. The reason that they want you to do this is that it's in a much easier form to answer the next question. So as t gets very large, e to a negative large power is 1 over e to a large power. The reciprocal of anything enormous tends to 0. So you know that when t gets very large, e to the minus 0.1t is going to virtually disappear. So as t gets large, n tends to 50a over a plus 0, and of course that would become 50a over a, which of course tends to 50. Now the last two parts, they're 1 mark parts of a hard question, a bit sort of more like chatty maths. You would say that you could refine this model. N is always going to be discrete. It should be a discrete exact number, and of course this model is going to give continuous values, so you could refine it by getting only integer values of n. And of course, why this model is not very good is really the same reason. It will give continuous answers, not discrete.